I am Russell Rosenkrantz with interesting technology news on the BrainSTEM channel. Today's episode is about research on a prototype device which allows people to listen to music through the sense of touch. The research is from Ritmo Center for Interdisciplinary Studies in Rhythm, Time, and Motion. People with hearing loss will be able to listen to music through the sense of touch thanks to a pioneering prototype that has been devised by researchers of the Department of Electronics of the University of Malaga, members of the R&D group Electronics for Instrumentation and Systems. It consists of an audio-tactile algorithm that, by using tactile illusions, renders the monophonic music into tangible stimuli based on vibration. It's like hacking the nervous system to receive a different response to the real stimulus sent. What we want to achieve in the long term is for people who do not hear to be able to listen to music, says the researcher of the PhD program in mechatronics engineering, Paul Remak, main author of this paper, who advocates on the power of music to influence mood as well as its possibilities as a therapy for mental disorders and the treatment of pain. This would result in a portable terminal that could be brought to a concert, since this prototype, according to the researchers, will be easily transferable to technological devices such as cell phones. The algorithm developed by this young researcher, along with the professors at the UMA, Andres Trujillo and Fernando Vidal, is capable of converting musical features and structures extracted from the MIDI files, musical instrument digital interfaces, to vibrotactile stimuli. It is something similar to mapping music, explains Ramaki, who adds that it is possible because this type of files not only can be played and generate sound, but also provide symbolic representations. Current models do not warrant the correspondence between the emotional response to music and the vibrotactile version of it. In view of this, these engineers of the UMA propose an arrangement of the tactile illusions in order to improve and extend the spectrum of musical features, adding dynamics to the vibration in the form of movement, changes of direction, and location. It is a challenging process since the perceptible frequency range of the skin is lower than that of the auditory system, which may cause the loss of some musical features, they explain. First experiments completed, in which over 50 volunteers took part, suggest that the arrangement of tactile illusions evokes more positive emotions than negative ones. They are also perceived as more agreeable and stimulating than the audio, provoking a different emotional response from that of the original music. The first prototype was presented in the 11th International Workshop on Haptic and Audio Interactive Design in the United Kingdom, the biggest international event specialized in these areas of study, after being published in the journal by the same name. At present, the researchers of the UMA are working on a second model and continue with the experiments. The research is the product of Paul Ramaki's doctoral thesis and is part of the National Plan Project, Smart Instrumentations and Application in Healthcare. Follow BrainSTEM University for more tech news. See you again next week.